Right, here we go. So, turn that off. Welcome to whoever's watching. 3 viewers at the moment. One of them could be me, so it might only be 2 of you. It's gone as high as 5 now, so that's good. I am just going to get this phone sorted. Right, what I'm going to do here is go through a few things that I've set to various classes on iMaths, but at the same time I've got my email open, so if anybody wants to suddenly mail me with a specific question, then hopefully I should see it come in, and then I can deal with it as and when. So I'll just put the my phone out of sight so you're not all looking at my email. 7 viewers now, spectacular. Okay, so I'm starting off with MYP1, and I've set a bunch of work on iMaths about fractions, and it's adding and subtracting fractions. Now the thing is with adding and subtracting fractions that in the bottom numbers, the denominators have to be the same. So this first bunch of questions is quite easy. A fifth plus 2/5. So the denominators, the bottom numbers, are already the same in that one. They're both 5. So all I've got to do is add up the tops. So 1 plus 2 is 3. So the first one is 3/5. Now, of course, iMaths being iMaths, you won't get the same questions that I get, but hopefully they all operate under the same principle. Okay, so question 2 on this. 7/9 minus 5/9. Okay, so again, the denominators are already the same. So the answer is going to be in ninths, and I've just got to subtract the tops. 7 minus 5 is 2. So the answer to that one is 2/9. Third one, a 7th plus 3/7. So the answer is going to be in 7ths, and we just add the tops. 1 plus 3 is 4, so the answer is 4/7. And then 5/8 minus 1/8. Again, the denominators are already the same. They're already 8ths. So the answer is going to be in 8ths. And I've just got to subtract the numerator, the top number. 5 minus 1 is 4. So 4/8. Now, in the case of 4/8, that simplifies to a half, because you can divide the top and the bottom by 4. Let me just put my big pad here. So 4/8 dividing by, you're not dividing by 4, but you're dividing by 4/4, which is like dividing by 1. So that's how you get a half. Important to stress that you're not dividing by 4, because if you divide it by 4, it gets smaller by a factor of 4. But 4/8 is actually the same size as a half. It's just written in a different form. So important to know that difference. Okay, then the second bunch of questions on that. Now try these questions using unlike fractions. So in these, the denominators are different, and you've got to make them the same. So let's just rip off that page. So the first one here, I've got 1/4 plus 1/2. So 1/4 plus 1/2. I need to think of a number that 4 and 2 both go into, and then write the fractions out of that. Well, 4 and 2 both go into 4. You can divide them both. We can divide both of them. What am I trying to say here? You can divide 4 by both of them. They both go into 4. So both of these fractions can be written as fractions out of 4. So 1/4 is still 1/4, but then 1/2 is the same as 2/4. So what you're doing there is you're multiplying the bottom by 2. So in effect, you're multiplying by 2/2, and 2/2 is the same as 1. So you're really only multiplying by 1. So I've changed it into 1/4 plus 2/4, and then I just add the tops, the numerators, to get 3/4. So 1/4 plus 1/2 makes 3/4. Okay, next one, 14/15 minus 2/15. Let's go over here. So 14/15 minus 2. Did I say 15ths? I meant fifths. So 15 and 5 both go into 15. So I can write both of these as fractions out of 15. So 14/15 remains 14/15, but then 2/5 becomes 6/15, because what I'm doing is multiplying by 3/3. I'm not multiplying by 3, I'm multiplying by 3/3, which is just like multiplying by 1. So I get 2/5 into 6 15ths. Okay, so 14 15ths minus 6 15ths. So you just subtract the tops. 14 is 8, and then the bottom number remains the same, 8 15ths. So all of these are pretty much like that. Shall I do the last ones? I might as well. Okay, so a third plus 4/9. Well, a third can be written as 3/9. So I can rewrite that as 3/9 plus 4/9, and 3/9 plus 4/9 makes 7/9. And then the last one, 10 and 80, well, they both go into 80, so I can rewrite them both as fractions out of 80. 80. Okay, so 31 over 80 is still 31 over 80. But then I've got to multiply the top and the bottom by 8 to get it into 80ths. So again, I'm not multiplying by 8 eighths. So 7/10 becomes 7 eighths of 56, 56 80ths. So I've got 56 80ths plus 31 80ths. Now this one's a bit tricky. I'm breaking a rule of mine here by writing two equal signs on one line, but never mind. 87 80ths, a top-heavy fraction, or you might call it improper fraction or a vulgar fraction. The top is bigger than the bottom, so I need to think to myself, how many 80s can I get out of 87? Well, that's 1, and then with 7 left over, so that's the 1 and 7 80ths. So in the boxes here, I'll write 1 and 7 80ths. Okay, down to 5 viewers. Lost 3 viewers there. We were up to the dizzy heights of 8. I'll just check my emails for any specific queries. See if anyone's mailed in. Just one from Ashley about MYP5, which I'm dealing with separately. So we'll just back to this. Okay, and then the second page of that with the adding and subtracting fractions for MYP1. Here it says changing both denominators. So the number that both denominators go into isn't one of the denominators that's already there. Okay, so we've got 2/5 plus 1/8. Let's just do that. 2/5 plus 1/8. So again, your questions will be different because that's how iMaths works. But 2/5 plus 1/8. I need to think of a number that 5 and 8 both go into. So the lowest common denominator that I can think of 5 and 8. Now I could just multiply the two numbers together. 5 times 8 is 40. So both numbers are sure to go into 40. That's one way of doing it. That won't necessarily give you the smallest number that both things go into. In this case, it does. 40 is the smallest number that they both go into. But that's not always the case. We'll talk more in MYP2 about how to find lowest common denominators of pairs of numbers. But in any case, let's proceed with this. So 2/5, I want to write it as something over 40. So I need to multiply the top and the bottom by, let's find a pen that I can see. If I multiply the top and the bottom by 8, then the bottom will be 5 times 8 is 40. So that will work. So that gives me 16 40ths. And remember, I didn't multiply by 8 there. I multiplied by 8 eighths, which is the same as multiplying by 1. So I'm not making the number any bigger or smaller. I'm just writing it in a different form. And then 1/8, I can multiply by 5 over 5, again, which is just like multiplying by 1. And then I turn it into 5 40ths. So 1/8 is the same as 5 40ths. So I've got two fractions that are both out of 40. So I can just combine them together into one big fraction, still out of 40. And 16 plus 5 is 21. So it's 21 over 40. So remember, adding and subtracting fractions, the bottom numbers, the denominators have to be the same, and then you just add or subtract if it's subtract the top ones. So that's 21 over 40. So if this was a computer, I'd be typing that in, but because I've printed it out, I'm just writing it in. Okay, let's do this one, I suppose. 9/10 minus 8/15. So 9 over 10 minus 8 over 15. So I want to write those as two fractions out of the same number. Now, obviously they both go into 150, so I could just do 10 times 15 and make them out of 150. But I can see that they both actually go into 30, which is a much easier, smaller number to work with. And again, we'll talk more in MYP2 about finding the lowest common denominator of two numbers. But you can sort of spot it with easy numbers like 10 and 15. So they both go into 30. So if I want to make 9/10 into a fraction out of 30, I'm going to multiply it by 3 over 3. So that becomes 27 out of 30. Then if I want to make 8/15 into something out of 30, then I've got to multiply it by 2 over 2, which makes it 16 over 30. So I've made it into 27/30 minus 16/30. So just subtract the tops. 27 minus 16 is 11, and then the bottom remains as 30. So it's 11/30. 11/30. Now, do I need to do the remaining ones? Let's do them anyway. So the next one is 1/8 plus 7/12. So 8 and 12, well, they both go into 8 times 12 is 90. Let me just kind of separate those off. It's a bit of a mess, but never mind. Yeah, they both go into 8 times 12, 96, but I'd much rather, if I can, write them out of a smaller number. So let's think of my 8 times table. 8, 16, 24. They can both go into 24. So 1/8 is the same as 3 over 24, multiplying by 3 over 3. And then 7/12, well, I've got to multiply 12 by 2 to get 24. So if I multiply by 2 over 2, that becomes 14 over 24. So 3/24 plus 14/24 makes 17/24. 17. Written it in the wrong one. 17/24. Let's just get rid of that. Last one, 10 in that block. 10/11 minus 5/9. I need a new sheet here. I think I should probably put this underneath so my pen doesn't keep going through and ruining the paper. Okay, 4/7. No, that's not the one. 10/11 minus 5/9. Now, in this case, the smallest number that they both go into is 99. So I'm going to have to make both of these fractions out of 99. So to get from 11 to 99, I've multiplied by 9. So I'm going to multiply the whole fraction by 9 over 9 to get 90/99. And then to get from 9 to 99, I've multiplied 11 by 11. So I'm multiplying the whole fraction by 11 over 11 to get 55 over 99. So that's 90 over 99 minus 55 over 99 makes 35 over 99. And let me just try and think whether 35 and 99 have got any common factors. 35 divides by 7 and 5. 99 divides by 3, 9, 11. So they haven't got any common factors, so that is the smallest way you can write that fraction. 35 over 99. Right, the last couple of questions on that. Write your answers as mixed numbers. Oh, goody. Okay, so 5/8 plus 7/12. Let me just separate this off with a nice neat ruler this time. That's a lot better. Okay, so let's think of numbers that 8 and 12 go into. So 8, 16, 24. Yeah, so I can write both of these out of 24. We had one with 8 and 12 before, didn't we? So I should have remembered that that was going to be out of 24. So 5/8 times 3/3 makes 15/24. So I've got to multiply by 3/3 to get 5/8 into 15/24. Then what do I need to multiply 12 by to get the 24? Well, it's 2, isn't it? So I need to multiply the whole thing by 2/2. So 7 times 2 is 14, and 12 times 2 is 24. So 5/8 plus 7/12 is the same as 15/24 plus 14/24, which is 29/24. And that's top heavy, or vulgar, or improper, or whatever you want to call that. So I need to write it as a mixed number. So 24 goes into 29 one time, but then you've got 5 left over. So the answer is 1 and 5/24. 1 and 5/24. Then the last one, 4/7 plus 7/9. Okay, let's have a look. Rule this off. 4/7 plus 7/9. Okay, so the smallest thing that both of those go into is 7 times 9, 63. There aren't any smaller common factors. So to get from 7 to 63, I'm multiplying by 9. So I multiply the whole thing by 9/9 to get 4 times 9 is 36. So 4/7 is 36/63. And then 9 I'm multiplying by 7 to get the 63. So if I multiply by 7/7, 7 times 7 is 49, 9 times 7 is 63. So 4/7 plus 7/9 is the same as 36/63 plus 49/63. So add up the tops, leave the bottom as 63, makes 85 out of 63. Now 63 goes into 85 one time, but then we've still got 22 left over. So that's the same as 1 and 22/63. Let me just think about whether that reduces. 22 divides by 2 or 11, 63 doesn't, so that fraction doesn't reduce. 1, not 11, 1, and 22/63 is my answer. Okay, so that's the MYP1 questions. I'm just going to take a sip of coffee now and check my emails for queries, see if anybody's contacting me, and give my voice a rest. Okay, so we've got an email from another MYP5. Is it possible for you to send me a list of what is most likely to be going on the MYP5 exam so I can study the right topics? Well, the key to that is just go through all the past exams. There's always going to be trigonometry. There's always going to be quadratics. There's always going to be something with straight line equations. But you'll see that there's 5 practice exams available. So we will have covered all of them by the time we get to the exam, so you will see that. But I will do a list as well. I'll try and do a breakdown of kind of which years what things has turned up, but not today. Okay, so get rid of that. bite of cake before we go on to the, it's got strawberry on the top. Brilliant. Right. Okay, so well, this is actually relevant to MYP2 and MYP3 because I've set the same thing to both classes. And it's rearranging equations. So it starts off with some fairly simple ones. So my first one, and remember, you won't necessarily get the same questions. So it says make x the subject of these equations. So what that means is rearrange them as x equals something with all the other letters. So at the moment, the first one, quite easy, x plus y equals w. I'm trying to get the x on its own. So I need to take away the y to get the x on its own. But because an equation is like a balance, I need to do the same thing on the other side as well. So I take y away from the, now I'm losing my voice, y away from the right-hand side, so it becomes w minus y. Second one, x over v plus w equals y. So whenever I see a fraction, I want to get rid of it as soon as possible. So I've got x divided by all this lot, v plus w. Now, whenever you see a fraction, it's as if there's a bracket around the whole of the top and the whole of the bottom. So if I want to get rid of that fraction, I can just multiply both sides by the whole of the bottom, v plus w, and then I get the x on its own. But I need to, that's a bit confusing because I've got a thing for multiply which looks like an x. So I'll multiply. Yeah, so because an equation is like a balance, I need to multiply the right-hand side by v plus w as well. So I've done it like that with the whole of the v plus w in a bracket. So x equals y times v plus w in brackets. Okay, some of these are pretty tricky, I have to say. Excuse me. Let's go on to this one that says x minus 6y equals 4v. Let me just separate some of these off. Boom. 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 Okay, x minus 6y equals 4v. I'm trying to get the x on its own. So I'd like to get rid of that minus 6y bit. And I can get rid of that by adding 6y. So I'm adding 6y. But because an equation is like a balance, I need to add 6y to the other side. So x equals 4v plus 6y. I've added 6y to both sides. And that's finished because it's written as x equals something with the other letters. And that's what I was trying to achieve. Okay, so we've done that one, that one, that one. Let's have a look at, well, this one with all the fractions looks pretty horrible. So that one says v over 5x equals w over y. That is indeed horrible. First thing I'd like to do is get rid of the fractions. So let's get rid of this fraction first. So I've got v divided by 5x. If I multiply everything by 5x, then it will get rid of or cancel out the dividing by 5x and just give me a whole big fat hairy v there. But I need to multiply the other side by 5x as well, because you've got to do the same thing both sides. So instead of w over y that was there before, that, but multiplied by 5x. So times 5x on the top, v equals 5w divided by y. Now, I've still got a horrible fraction there because I've got this fraction that says something divided by y. So I'd like to get rid of that, and I'm going to cancel out the dividing by y by multiplying by y. So if I multiply by y, it cancels out the dividing by y, and I just get 5xw. But I'd like to, but I've got to do the same thing on the other side. So v that's already there multiplied by y gives you vy. Okay, and then I'd like to get the x bit on its own. So at the moment I've got x times 5 and times w. So if I divide by the 5w, it'll just leave me x on its own. But then I've got to do the same the other side. So vy over 5w is equal to x. So that's my final answer, that x equals v times y over 5w, 5 times w. Pretty horrible one, that. But there you go. Let's do a couple more. Let's do the last one on this block. Now, by the way, if there are any specific ones that you get that you're stuck on, do just mail them in and I'll try to deal with them. Well, today if we get time, if you do it quickly enough, or tomorrow or whatever. Okay, so let's just do the last. 3w plus vx equals y. So again, I'm trying to rearrange that into x equals something, something, something with all the other letters. So I'd quite like to get this vx bit on its own, because that's the bit with the x in it that I'm trying to isolate. So I'd quite like to take away that 3w. So I'm going to take away 3w to make that vx, or to isolate that vx. But I need to do the same on the other side as well. So y that was there before becomes y minus 3w. Okay, so vx equals y minus 3w. I don't want to know what v times x is. I want to know what x is on its own. So to get from v times x to x on its own, I'm going to divide everything by v. But because an equation is like a balance, whatever I do to one side, I have to do to the other side as well. So I need to divide the other side by v as well. So that's rearranged it into x equals y minus 3w over v. Excuse me. Yeah, that complicated one. Okay, so I'll leave those for now. I can see we've got 25 minutes of this session left. See if I've got any mails. Sip of my coffee. Okay, so no more questions from anyone, but do mail them in to me at the school if you've got any specific ones. Right, same thing, but with brackets. Make x the subject of these equations. Okay, so these are quite tricky. By the way, I've set these for MYP 2 and 3, but they are quite challenging for that grade level, so don't be too terrified by them. I am kind of pushing the envelope a bit on this one. So a brackets x plus b equals c. So I'm trying to get x on its own. So at the moment I've got a times a bracket equals c. So yeah, a letter just in front of a bracket means multiplying. Okay, so I'd quite like to get that bracket that's got the x plus b on its own. So if I divide by a, that'll give me that on its own. but I need to divide the other side by a as well. So dividing both sides by a gives me x plus b equals c over a. Now, x plus b doesn't really need those brackets around it anymore. So x plus b equals c over a. And if I want to get the x on its own, I just take away the b. Then I've got to do it from both sides. So x equals c over a that was there before. Take away b, because I'm taking away b from both sides to get the x on its own. So it says in the question, there are two ways to rearrange each equation. Okay, so one way I just did it was c over a minus b, x equals c over a minus b. Or another way is you can write it as one big fraction. So if I want to write all of that as just one big fraction, then I need to think that b is the same as b times a divided by a. So I'm just times a dividing by a. But the reason I picked a there is so that I've got two fractions that have both got the same denominator, a. So that's the same as c over a minus ba over a, which I can write as one big fraction over a, c minus ba all divided by a. So it ties in a bit with the stuff I was doing for the MYP1s earlier, with fractions having to have the same denominator. But it's a little bit abstract because it's all letters. Finally, a little bit neater to just put that in alphabetical order. So rather than BA for B times A first, then B. So X equals C minus AB over A. So that's the other way of doing that one. C minus AB over A. So all of these are kind of like that. I will not do all of them, but do email me with any specific ones you're completely stuck on. Time for a piece of cake. Diet starts tomorrow. And some coffee. Just check for any emails. Okay, no one's mailed anything in yet. Okay, so next bit, rearranging 2. I've set this for the MYP2s and the MYP3s. Subject on both sides. Let's just get a fresh piece of paper. So we've got, so my first one says 7x plus v equals 4x plus w. And I've got to rearrange that as x equals something with all the other letters in. So with the x on both sides, the first thing I ought to be thinking about doing is how much x can I take away from both sides? So just like when I did this in class with bags of jelly beans, how many bags of an unknown quantity of jelly beans could I take away from each hand of the person that was standing there? How many x's can I take away from both sides? Well, I've got 7 x's here, only 4 x's here. So the most x I can take away from both sides is 4x. So if I take away 4x from the right-hand side, that just leaves me with the w, and all the x's are gone. And then if I take away 4 x's from the left-hand side, I've got 7 x's there. Take away 4 x's, that leaves me with 3 x's, and then this other thing, v. So 3x plus v equals w. I'm trying to get the x on its own, so I'd like that v to disappear. So I'll take away the v. But because an equation is like a balance, I've got to do the same the other side as well. So I take away the v from the other side, and I get 3x equals w minus v. I don't want to know what 3x's are. I want to know what 1x is on its own. So I'm going to divide it by 3. But because an equation is like a balance, I need to do exactly the same thing to both sides. So I divide the other side by 3 as well. So I get x equals w minus v divided by 3. X equals w minus v divided by 3. Oh, now the next one's tricky. Let me just roll this off. So I've got ax plus 4 equals 2x plus b. So I've got x's on both sides, but on the left-hand side, one of the x's is some unknown quantity of it, a. So what I can do here is, tell you what I'm going to do is just space this out a little bit more. So forget I wrote that. See why in a minute. I'd like all of the x's on the one side, and I'd like all of the other things on the other side. So if I take away 4 from both sides, then I get ax equals 2x plus b minus 4. So I've just taken away 4, so 4's disappeared from here, and then I've got a minus 4 over here. And then if I take away 2x from both sides, then I've got ax that was already there. Take away 2x equals, I've taken away 2x, so that disappears, and then b minus 4. So ax minus 2x equals b minus 4. Okay, so I've got all of the x things on the left and all of the other things on the right. Now, we're going to do a thing here called factorizing. Ax minus 2x, both of those things have an x in them. So I can write that as a multiplied by brackets, x multiplied by brackets a minus 2, because if you multiply these brackets out, x times a gives you the ax, and x times minus 2 give you the minus 2x. So x times brackets a minus 2 equals b minus 4, and then I can divide by the whole bracket to get x on its own equals b minus 4 divided by everything that was in that bracket, a minus 2. Yeah, to be honest, that's a little bit. I'm just trying to think. Did I set that for MYP 2 and 3 or just 2? Can't quite remember. I think I possibly set that for MYP 2 as well as 3, which is a little bit more than you can do at the moment. So I will put up sometime this week a new video about factorizing and how to do that. So don't panic about it at the moment. Plenty of opportunity this week to get in touch with me, and I'll do more explanations of those in the coming days. Okay, so what should we do now? Factorizing with letters, linear factorizing. Okay, so this was just for the MYP3s, I think. So factorize these expressions as far as possible. 4a squared plus 5ab. 4a squared plus 5ab. So I need to think about what things I can divide all of the terms by. So all of these things have got an a in them, so they can all be divided by a. So I can write the whole thing with an A outside some brackets. And then I'm saying, what do I need to multiply the A that's outside the brackets by in order to get the inside the brackets in order to get the thing I started with? So what do I need to multiply A by in order to get 4A squared? Answer is 4A. 4A times another A gives you 4A squared. Then what do I need to multiply A by inside the brackets in order to get 5AB? So the answer is just 5B. 5B times A give you 5AB, 5 times A times B. And that's the answer to the first one. Next one, 6P plus PQ minus 7PR. 6P plus PQ minus 7PR. Okay, so all of those things have P in them. So I can divide them all by P. So I can take a P outside some brackets and then say, what do I need to multiply the P by inside the brackets in order to get the thing I had before? So P times what will give you 6P? Answer 6. P times what will give you PQ? Answer Q. P times what will give you minus 7PR? Answer minus 7R. Minus 7R times P will give you minus 7PR. The order of those letters doesn't matter. 7PR, 7RP all mean the same thing. So that's that one factorized. So 6P plus PQ minus 7PR can be written as P brackets 6 plus Q minus 7R. Okay, I won't do every single one of these, but I'm going to go down to the last one because that's super tricky. 27 PQRS plus 63 Q squared RS minus 45 QRS. Let me just rule that one off. So I need to think, what can I have inside the brackets multiplied by, well, as much as possible I want. So I want the biggest thing that all of these terms can be divided by. So they've all got a P in them. Well, no, they haven't. That one's got a P in it. That one hasn't got any P's in it. That one hasn't got any P's in it. So I can't take any P's outside the brackets. This one's got a Q. This one's got a Q squared. This one's got a Q. So they can all be divided by Q. So I can take a Q outside of the brackets. This one's got an R in it. This one's got an R in it. This one's got an R in it. So they can all be divided by R. So I can take an R outside the brackets. And they've all got an S in them as well. So I can take an S outside the brackets. And then the numbers at the start of them, 27, 63, 45, they can all be divided by 3. I'm just trying to think if they can be divided by anything bigger. Yes, 9. They can all be divided by 9. So every one of these 3 terms can be divided by 9QRS. Wow. So what do I need to multiply 9QRS by inside the bracket in order to get the thing that I had before? So what do I need to multiply 9QRS by in order to get 27 PQRS? I need to multiply it by 3 so that I get the 9 times 3 making the 27. I need to multiply it by P so that I get the P. I don't need to multiply it by Q or R or S, and any more Q's or R or S's, because I'm already multiplying the 3P by QRS to get the QRS. So 9QRS times 3P give you 27 PQRS. Wow, so that's the first term. Next one. What do I need to multiply 9 by to get the 63? That's going to be 7. What do I need to multiply q by to get the q squared? I need to multiply it by another q. What do I need to multiply r by to get the r? Well, I don't need to do any more multiplying because the r is already there. And then the same applies to the s. So 9qrs times 7q gives you 63q squared rs. Wow. Next term. What do I need to multiply the 9 by to get the minus 45? That's going to be minus 5. And then it's already got QRS in it, so I don't need to do any more multiplying. So I've actually got to my final answer that 27 PQRS plus 63 Q squared RS minus 45 QRS equals 9 QRS times 3P plus 7Q minus 5. Now I realize that looks very daunting with all of the letters in it, but the underlying principles are fairly straightforward. So if you can do the easy ones at the start, then the ones at the end are just the same principle but with more letters. So it's just a question of keeping track of it. Okay, so that's probably all I want to go through today from the iMaths. Let's just see if anybody else has contacted me. Not a soul. 8 viewers at the moment. I wonder who that is. I think one of them's me, so 7 viewers. I might just leave it there then, but do get in contact if there's a specific thing on the iMaths that you're stuck on, a particular question that you keep getting wrong and you don't understand why. You can email me a screenshot of the question you keep getting wrong, or describe it to me. Screenshot's probably the easiest way to do it. So I think I'll wind it up there. So back again, same time tomorrow, 12 o'clock. Do get in touch if you're stuck.